What we're going to do tonight is go through what I'd call the moral basis for your professional life. So this is where engineering meets philosophy. And so naturally, I've invited my other meetup group, the Deep Thinkers. And we've also got a few more coming from the Engineering General Practitioners Group, or EGP. So that's why we've got quite a few guests here tonight. And it's one I've done before, but like Lord of the Rings, the tale grew in the telling and continues to grow as well. I must warn you that it may contain some British humour, being British, and also, if you need trigger warnings, this may not be the meetup group for you as well, particularly if you're overly sensitive. We will be discussing some traumatic events. It's also a personal journey of mine through my career, or partly through my career. There will be some personal reflections. Now, it might either be the meandering memories of an old man, or it may be some wise words from an experienced engineer. So, if you remember back in 2010, Qatar were awarded the FIFA World Cup, and many people wondered whether that was ethical or right. And surprise, surprise, in 2015, they were indicted on charges of bribery and corruption, and Daryl Blatter was removed from his position. Back in London, there was a big fire at Grenfell Tower, and the person who was in charge of the firefighting operations, the fire chief in London, said she'd never seen a fire like this in her entire professional career. However, I had, and we'll come to that in a moment. But this basically is the consequences of unethical behavior. And the consequences of unethical behavior for engineers is that people die. And reports have come out since, and there's plenty of discussions available on the internet to see that this behavior was knowingly unethical at the time. And they even avoided proper testing and marketed their product dishonestly. And surprise, surprise, Kingspan directors cashed in some of their shares before these claims were made. It was clad in aluminium, an aluminium composite cladding, and there many have said, well, we didn't know it burnt, which reminded me of a film I saw. This is a film called Pentagon Wars, and it was on a trip flying back from the USA that this was the in-flight movie. And it's a film about the development of the Bradley fighting vehicle, and it's highly entertaining. And there's a point in it where chap on the left says we have a report from the British saying that aluminium burns when hit by fire. And Kelsey Grammer replies, well, we fought a war so we don't have to listen to those bastards. We'll come back to this because there's a postscript. I'd seen a fire like that, and back in 1973, this is a building called Summerland in the Isle of Man. It's probably the worst disaster to hit the Isle of Man, and you can look it up on Wikipedia, and there's several articles on it. It happens to be the 50th anniversary next month, and there's a personal involvement because the girl on the left there is Jane. Jane's brother was married to my sister, and Jane was killed in that fire. The girl on the right is Jackie, and she survived either by jumping or falling about 40 feet, but was obviously badly injured. And she is going back to the Isle of Man next month in the hope of getting an apology from somebody, because nobody has been held account for this. And 50 people were killed in this fire. It didn't comply with building regulations at the time, and they almost deliberately flouted the regulations. Coming closer to home in New Zealand, there is the collapse of the CTV building in Christchurch. Now, some may think that's just the result of an earthquake. But there are so many issues with that building that some of the issues would be down to unethical behaviour, including an identity theft of the person on site. And New Zealand has leaky buildings, and this is a great book. I highly recommend it. It's called Rottenomics, and it's the story of New Zealand's leaky building disaster. And it tells you why it happened and how it happened, and you can't help feeling that quite a lot of this was unethical behaviour. And only last week we found out that there are many homes in the North Island of New Zealand which were signed off by somebody pretending to be a chartered engineer. So yeah, there's fraud and corruption even in New Zealand. But Engineering New Zealand has a code of ethical conduct. It's a relatively short and simple document. Here are the points it makes, and it's split into two. The first is your obligation as an engineer to the public interest. So that means you need to take reasonable steps to safeguard health and safety. You should have regard to the effects on the environment, and you need to report adverse consequences. In terms of your personal conduct, you're supposed to act competently and behave appropriately and inform others of the consequences of not following advice. So if your client or a contractor is following bad practice and going against your advice, you're supposed to tell them the consequences and likely consequences of doing that. Maintain confidentiality. So we all work within contracts within commercial organizations, and report any breach of the code. Now, Engineering New Zealand has limited capability in terms of sanctioning against people pretending to be engineers. It can really only affect those members of Engineering New Zealand. There's another document on the Engineering New Zealand website, and it's called Bounds of Competence, and it goes through quite briefly and quite succinctly, I think, the idea of people move from being unconsciously incompetent to being unconsciously competent as your career develops. Now, some people only stick at level 1. So what does it mean to be unconsciously incompetent? Basically, you don't know what you don't know. And research recently has shown what's called the Dunning-Kruger effect, simply because it was developed by Mrs. Dunning and Kruger. People aren't half as clever as they think they are. And some time ago, I think it's during the Gulf War, Donald Rumsfeld famously quoted, "There are known knowns, known unknowns, and unknown unknowns." And he was ridiculed as a fool. However, Ludwig Wittgenstein had said something very similar nearly 100 years ago and was regarded as a bit of a genius. So unconsciously incompetent, this is the unknowns unknowns. Many people don't know what they don't know and what they should know. If you're consciously incompetent, you've moved on to the next level. You've recognized there are things that you don't know, but you need to know. Hopefully, as your professional career develops, you'll become competent and consciously aware of your strengths and your weaknesses and your expertise in their work. And finally, when you're an expert, then you'll be unconsciously competent. You won't have to think about theory and think about what you're doing and be able to solve tricky issues. This is accompanied by simple diagrams. So if you're unconsciously incompetent and you're practicing as an engineer, then that's likely to be dangerous. There is a gap in your knowledge and you're creeping into it. When you're consciously incompetent, you know that there's additional knowledge that is required to do your job. However, you know how and where to get it from. And the goal, of course, in your professional career is to become consciously competent. You just know what you're doing. And you're always working within the bounds of your competence. Now, as you develop as an engineer, those boundaries will continue to grow. Now, part of this presentation is based on a workshop I went to about 10 years ago by the Institution of Civil Engineers. And this was an interactive workshop. And they even said at the end of it, please do this in your workplace. So I did. And there is a number of case studies, which we may briefly address a little later. And you're supposed to break off into little groups and discuss each of the case studies. Now, that particular workshop is no longer available through the ICE workshop, but a similar one is, and they've updated the case studies. So I suggest you go over to the ICE website to find that. But this is the thrust of that workshop. And so, pardon me for reading it out, but I think it's worth it. Ethics is often defined in two ways. The Cambridge Dictionary gives the following two definitions. So ethics is a system of accepted beliefs that control behaviour. It's the study of what is morally right and what is not. So as an engineer, engineering uses ethics as a cornerstone of our profession. It's a key element to distinguishing and differentiating us as a profession and professionals within that profession. It's not just about avoiding bad decisions, although that's part of it. It's about choosing good ones. So the significant contribution that engineering makes to a society invokes an inherent duty on us to act ethically. So we like to think there's a strong tradition of ethics in engineering, and institutions around the world try to impose that on their members. And in some countries, you're often asked to pledge to this code of ethics. Here in New Zealand, we're supposed to commit to the New Zealand Engineering Code of Ethics every year. So this is the Code of Ethics for the ICE. It's a little bit bigger than the Code of Ethics for the Engineering New Zealand, but covers some of the same ground. And it's divided into 6 areas, which we'll go into one by one. So it's laying down a framework and some rules and to cover basic aspects of your profession and your professional conduct. It's a commitment to professional standards as well as your obligation to society. So beginning with rule 1, engineers need to act with integrity. What does that mean? You have professional duties, so therefore discharge those professional duties with integrity. Number 1, you have a duty of care, and it's not just to your client. Some think that the golden rule means that those who hold the rules, those who hold the gold, make the rules. However, your duty of care extends beyond that, as we'll see in later rules. Your duty of care extends to the general public and all the stakeholders involved in that construction project. Act with honesty. It's almost something you shouldn't have to say. Act with honesty. Now, we work with written agreements. We have professional contracts, and hopefully we'll have professional insurance, indemnity insurance, and liability insurance, and make it clear that you are not stealing other people's work, and have respect for all of those that you're working with. Competence. So it's hard to get through to a lot of people that you need to work within your own levels of competence. But to do that, you need to know what your level of competence is. And this will often mean going to seminars and testing the body of knowledge and skills that's laid down by, for example, SecEd, and testing yourself against that. And hopefully you will grow in those competencies and those skills as your profession develops. Public interest, number 3. The first duty, actually, of a civil engineer or a structural engineer is to the general public. It's not to your client. And so overarching, there should be in your head your commitment to the health and safety of all those involved, and you'd like to prevent the disasters that could occur as a result of your work or your colleagues' work. Take into account all the stakeholders involved in the project, and what impact your project could have on society or future generations. Rule 3 is about sustainability, so don't mess up the neighborhood, as it were, don't trash the neighborhood. Show some regard to your environment, and as a civil and structural engineer, you should always try to make the best use of the resources available and try to avoid waste. Rule 5 is about CPD, and tonight is a fairly good example of you joining in with CPD. And you need to acquire so many hours or so many days in each of your professions to develop your skills, expand your knowledge, and keep on improving the bounds of your competence. This means keeping in touch with your colleagues as well as the engineering professions. And number 6, notify the institution if you've been convicted of a crime or become bankrupt or disqualified as a company director. And the last bit is you need to grass up your mates. Basically, if you have come across any unethical and illegal activities by another member of the institution, then there is a opportunity for you to report it to the ICE. So the ICE has put together this decision-making flowchart. And it's to help you make a decision when faced with an ethical dilemma. And the idea of this little chart is you keep it handy while going through those case studies. So you identify the options you have and then ask yourself these questions. So you start with, would my actions be legal? Again, it's a question that you shouldn't have to ask. Of course, you should be acting legally, but just check. And we're working within a legal framework. Take account of what you're doing within that legal framework. And the next stage is, do they satisfy professional codes of conduct? So some things may be legal, but not necessarily ethical and within the professional code of conduct. The next step is, have you considered all the stakeholders? So it's not just the client, but also the environment around you and the people involved, the general public, other stakeholders to the project. Are there conflicts of interest? Is an interesting one. Are you recommending something or a product because it would make you a little bit richer? The final question is, how would your actions be perceived? And the acid test is, how would it look if it was reported in the news or in the daily papers the following day? Ethics starts within your own organization, and it starts from the top. So the ethical framework set by your senior management is the ethical framework that your graduates will pick up on. So if your directors and your managers are behaving unethically, then so will your staff, so will your graduates, and that's where they learn. So senior management, senior engineers need to lead by example and demonstrate how they're accountable to those ethical standards. As part of that company, they should have ethical codes, so statements of values, codes of conduct, ethical policies within their company policies. Those should be quite similar to those ethical codes of conduct published by ICE and Engineering New Zealand. So is that message passed across, or is it lost in translation? So how do the messages from the top, from senior management, from senior engineers, get transmitted down to junior engineers and graduates? So if the messages are simple and consistent, then the chance of working in an ethical manner is likely to be improved. A way of applying it is to do these case studies, go through these hypothetical case studies as a lunchtime session, for example, and see what your colleagues would say. And this is where you find out how unethical your colleagues are. So the ethical toolkit goes out in more detail, and it does a number of case studies. I won't go through them all, but I'll highlight a few of them. So case study number 1 that we were supposed to go through is about procurement. So your manager asks you to prepare a tender document for the design stages of a large infrastructure project. The design brief from your client has specified a preference for a construction method that uses sustainable technology in order to meet the client's green targets on the project. You discover that nobody within the company has experience of this method, and using a subcontractor would be too costly to the project. You bring this to your manager's attention and are advised to finish preparing the submission without directly addressing the lack of experience in the text. It is suggested that the method will be researched in further detail if the tender is successful. So this is basically fake it till you make it, and we're going to wing it. So this can start quite an interesting discussion within your group. So that's case study number 1. Number 2, duty of care. You are managing a program evaluating the condition of your client's wide-ranging, high-risk asset base. You have an established professional relationship with a client, and your line manager stresses that we would like to maintain this because you are interested in bidding for future work from them. The ranges of asset types and materials have proven to be more considerable than you initially anticipated. The project is overrunning, and the client has criticised the depth of analysis used in your assessment and attributes the delays to this. The client puts pressure on you to finish the project quickly and asks you to simplify the assessment process, but you have concerns that this will lead to inadequate characterization of risks. This is a common feature. Again, go away, break up into little groups and discuss among yourselves. Health and safety and well-being is case study number 3. You have just started working as a sole structural inspector on a residential construction site. Upon your first few visits to the site, you notice a blatant disregard for health and safety, with project staff working in treacherous conditions. You raise the issue with the contractor, who assures you that you will always have safe access to the point of inspection and that the inspector before you never raised any concerns. In any case, the project is behind schedule and the speed of construction must be prioritized. Yeah, this is again a common occurrence. The fact that nobody's ever complained before is irrelevant. The fact that it's behind schedule is also irrelevant. The safety of the people on site is your concern, as well as the safety of your own. And so if a building site is not safe to inspect, then you don't inspect it, and they do not pass the inspection. It's as simple as that as well. Then again, I'm sure you'll come across many of that. Case study number 4, health, safety and well-being. You notice that a junior colleague appears to be suffering from significant stress levels as a result of the high level of responsibility on a very sensitive project. Over a brief discussion with your manager, you learn that the project is under-resourced and that your colleague has barely slept for over a week. Your manager appears reluctant to commit more resources to the job as the profit margin is already quite low and the division within the business is struggling. Your manager mentions that many young engineers would grasp at the chance to take on this level of responsibility so early on in their career, and that this is a fantastic opportunity for your colleague's career progression. Your manager mentions that your colleague is delivering the project successfully, and in any case, there are only a few months remaining on the contract. I can think of some choice words for that manager, and none of them are good. But this is again is a common occurrence that young staff, young engineers are put under a lot of pressure to perform and can quite easily burn out. There are several more case studies, but I'll leave it at that for the moment. We'll come back to the rest of the presentation. So coming back to our seminar number 3, which was learning from failure. And I put this one in. This is Florida International University, which collapsed in 2018, and it collapsed during construction. And no, it didn't fall down because it was designed by women, but it's just a pity that it was used as the poster project for women in engineering and then collapsed the next day. One of the issues actually is nobody would speak up about the issues with this bridge. It was novel and it wasn't checked properly. And again, we'll come back to that in a moment. So coming back to seminar number 4 about inspections. Well, the philosophy of inspections applies as well to many things in your engineering profession. So if you want to behave ethically as an engineer, you might not be popular, particularly if you've got an client who is very demanding and not particularly ethical, and is demanding from you to sign it off and constantly saying, is it safe? Ah, but it'll never fall down. Buildings don't fall down, do they? Now, when I was a graduate engineer, at graduate induction, Sir O'Varap appeared and he gave a little chat. You know, it's a bit like a guru around disciples. And he said something very profound, and I listened very carefully to what Sir O'Varap said. He said, engineers must think. That's quite profound. So as I've said before, whether you're doing inspections or for all of your engineering work, engineers must think. So use your little grey cells. And don't forget, everybody lies. As a news presenter, or was a news presenter, called Jeremy Paxman for the BBC, who was quite a fierce interviewer, particularly of politicians. But his approach was, why is this lying bastard lying to me? So it gives you a healthy degree of skepticism if you recognize that pretty much everyone lies. So some parting thoughts from the presentation. So I was talking about the bridge collapse at Florida International University, and part of it was no one would speak up. The bridge was cracked even before it was erected, and once it was erected, the cracks got bigger, and they had lots of meetings, including all the engineering staff there, and they pretty much dismissed the engineers' concerns for the cracking and thought the cracking would be solved by adding more load to it. And the result of adding more load to the bridge was that the bridge collapsed. And as I say, nobody was prepared to point out that the emperor had no clothes, because nobody likes to show their bare ass in public. Most of us don't. The issue is nobody likes to show their ignorance in public and are sitting in meetings thinking everybody knows what they're talking about. But sadly, that is not always the case. You may be the most knowledgeable person for that subject matter in the room. It's up to you to speak out. And the great Stan Lee gave a great line to Uncle Ben, because knowledge is power. And you have knowledge. You've all got degrees. You have some skills around engineering. And knowledge is power, but with great power comes great responsibility. So it's up to you to step up and use that. And when I was awarded my first Dan black belt, the senior instructor, Sensei Perry, said something very profound there. That just because you've got a black belt doesn't mean you're better than anyone else. It just means that your circle of responsibility has grown larger. So just because you've got a degree in engineering doesn't mean you're better than anyone else. It means that your circle of responsibility is slightly larger than everybody else's. And as a senior engineer, as a chartered engineer, your circle of responsibility is even larger. So just as the black belts are responsible for all the Q grades, the white belts, red belts, blue belts, and so on, then your senior engineers are responsible for the development of the junior engineers too. So sometimes you may be that one-eyed man in the kingdom of the blind. And sometimes you have to think, what's the worst that can happen? So for any engineering design or even any engineering decision, you need to think about who's it going to kill as well. But I must address the elephant in the room. And this is the elephant in New Zealand. And it's called the tall poppy syndrome. I have to give thanks to Dali for this particular image. Note that the poppy is larger than the elephant. No one, or it seems no one in New Zealand likes to stand out. And if you point out that the emperor has no clothes, or that your bridge is likely to fall down, or that your building is no good, you'll be marked out as a tall poppy. And if you point out that the New Zealand standards aren't particularly high, then you'll also be marked out as a tall poppy. This is to the detriment of New Zealand, and I think this needs to be smashed out. People need to stand up and not be afraid to be noted as a tall poppy. So we invited the deep thinkers, so let's have a little philosophy. And from Immanuel Kant, he's reputed as saying, he didn't actually say this because he was German, but I've paraphrased and translated into the succinct thing. What does it mean to be ethical? Well, do the right thing because it's the right thing to do. And don't do the wrong thing because those things are wrong. And he achieved that because he was thinking of reason. And he thinks that any right-thinking, reasonable person would come to those conclusions. His mistake, of course, is assuming people are reasonable. On the other hand, we have emotions. And there's a Professor Steve Peters from Sheffield University, possibly the greatest university in the world. Well, it was when I went there. And he developed this mind management tool, and he's called it the chimp paradox. And it's quite interesting. It explains a lot of things. Because we evolved from primates, because we've basically got a chimp brain inside of us, a lot of our decisions are made based on emotion rather than based on reason. And sadly, a lot of people can't handle the truth. But as Team America said, there are three kinds of people, and some of those people are unethical and they may know they're unethical. Another kind of person thinks they're ethical but results in unethical behavior as well. So some links here to the Institution of Civil Engineers. So the ethics toolkit, the up-to-date ethical toolkit is available from the ICE website. And from Engineering New Zealand, you can find the notes on practice notes on how to be ethical in accordance with Engineering New Zealand. The guidelines about ethical behaviour within Engineering New Zealand are on their site, as well as those bounds of competence. Now, like all good Marvel movies, I have a end credit scene. There's a postscript, Pentagon Wars. I had a look at it again this weekend. Now, the book has been withdrawn and the film has been withdrawn, but you can get hold of it on YouTube. So just Google, just go onto YouTube and search for Pentagon Wars. It's worth a watch. The story is the story of the Bradley fighting vehicle, which eventually was built and did serve and still serves in the Middle East. But these were the closing scenes. He won his fight to have the Bradley modified. As a result, casualties during its use in the Gulf War were significantly reduced. However, officers were promoted and others were in high-paying positions in the defence industry. He, unfortunately, was forced to retire. It's not easy being good. So, to my next seminar for the structural engineers will be on precast concrete. That's back to techie things and part one of the theory. For the deep thinkers, that's in a week's time. We're going to be talking about COVID, lockdowns, vaccine, masks and mandates. So nothing too controversial there.